Hello and welcome students. In this lecture of lines, we are going to, in this lecture of lines, that is 3D lines. The name of the topic is lines and planes. And what we are doing is, right now we are dealing with lines. And in this lecture of lines, I'm going to teach you how to find the shortest distance between two skew lines. What I'm going to teach you is to find shortest distance shortest distance between two skew lines. Okay, now I request you all to watch the video just previous to this video. Just previous to this video, you have to watch the video in which I have given the detailed explanation about skew lines and the shortest distance between two skew lines. So those who have not watched that video will have to watch the video just previous to this in order to understand here. So skew lines are those lines which are in space. They are not parallel to each other and they are also not intersecting each other. So here you have L1, L2, two lines which are skew lines. L1 and L2, they are not parallel. At the same time, they are not intersecting. Line L2 is going under line L1. See, it is going under line L1. Okay, this is going under line L1 and line L2 will, this way it will go under line L1. Okay, and line L2 will go under line L1. L1 line is over L2. I'm given the equation of, these are two skew lines. I'm given the equation of line L1, and L1 equation is R bar equals to A bar plus lambda B1 bar. A bar plus lambda B1 bar. Now you know, in this equation, A bar is the position vector of given point on the line. B1 bar is the vector parallel to L1. Lambda is the parameter. The equation of line L2 is given as R bar equals to B bar plus lambda B2 bar. Now here B bar is the position vector of point B on the line. B2 bar is the vector parallel to line L2 given to us. Okay, you know these are the minimum required data for finding the equation of a line. You should have one point on the line and a vector parallel to the line. Now next what I do here is, see, I have to find the shortest distance. I have explained this in detail in the previous video that the shortest distance would occur along a segment which is along a line or along a segment which is perpendicular to both. It is perpendicular to L1 as well as perpendicular to L2. So think this is the segment which is perpendicular to both. It is perpendicular to L1 as well as L2. What I mean is this. See, See, this is what I mean. Along PQ, this PQ is the shortest distance between the two lines. Shortest distance between two lines is PQ. This PQ, segment PQ is perpendicular to L1 at point P, and it is perpendicular to L2 at point Q. As such, you know there are infinite points on both the lines, but you will join any 2 points on the lines. The segment may not be perpendicular, but if it is perpendicular along a segment, then that segment length is the shortest distance. Now the idea here is, see, if you want to get PQ, what you will have to do is, you will have to project AB bar. What are A and B? They are the given points on the lines L1 and L2. I was saying, if you want to get the shortest distance PQ, the shortest distance here is PQ. Shortest distance between the lines equals to PQ. If you want to get this PQ, what you will have to do is, you will have to project AB bar on a vector which is parallel to PQ bar. On a vector which is parallel to PQ. I repeat again. If you want to get the shortest distance PQ, for that what you will have to do is, you will have to project, this is projection of vector, one vector over the one vector on other vector. So if you want to get PQ, you will have to project vector AB bar, you will have to project vector AB bar on a vector which is parallel to PQ. Now, which vector can be parallel to PQ? That is, which vector can be perpendicular to L1 and L2 both? See, if I find B2 bar cross B1 bar or B1 bar cross B2 bar, that is okay. Students, if I find B2 bar cross B1 bar or B1 bar cross B2 bar, what I'm trying to tell you is, if I find the cross product of these two vectors, if I find the cross product of these two vectors, which two vectors? B2 bar and B1 bar. If I find the cross product of these two vectors, then the cross product of these two vectors will be perpendicular to L1 and L2 both. The vector, see, this is B2 bar. Okay, I take it here. Now, what you see is B2 bar shifted. See, B2 bar and B1 bar, these two vectors are parallel to L2 and line L1. If I find the cross product, B2 bar cross B1 bar, you know the cross product will get us another vector which is perpendicular to both the vectors. I shall get B2 bar cross B1 bar, and that vector will be in this direction. You see this? I will get a vector in this direction. And if I am finding B1 bar cross B2 bar, then it will be this way. See, this vector is B1 bar cross B2 bar. Okay, it is going by right hand thumb rule. So here, this is B1 bar cross B2 bar. You can check B1 bar cross B2 bar is perpendicular to both. It is perpendicular to B2 bar. It is also perpendicular to B1 bar. And if you have B2 bar cross B1 bar, then B2 bar cross B1 bar will be this way. And this is also perpendicular to both. See, it is perpendicular to B1 bar. It is also perpendicular to B2 bar. So what I will do is, let me make a small change here. Instead of shifting B2 bar, I will shift B1 bar. So here I get, see. Okay. This is vector B1 bar. This vector is B1 bar here. So now I'll find out the cross product of these two vectors, B2 bar cross B1 bar. And the cross product of the vectors will come this way. See, it will be perpendicular to both. It will be perpendicular to B2 bar and B1 bar both. See, it is perpendicular to B1 bar and perpendicular to B2 bar. What vector is this? This is vector B2 bar cross B1 bar. Now remember, when I will project this AB bar vector, when I will project vector AB bar on this, what is meaning of projection of one vector on another vector? From the extreme points of the vector. So here the extreme points are A and B. That is initial point and terminal point. When I draw the perpendicular. So see, when I draw the perpendicular from A on this vector B2 bar cross B1 bar and B on this vector, what I will get is PQ. See, when I draw the perpendicular, okay, from here, and I draw the perpendicular from here, okay, the projection of AB bar on B2 bar cross B1 bar will give me PQ. That is what you have to remember. So here I write, see, now I start writing. I will write here PQ equals to projection of AB bar on B2 bar cross B1 bar. Now this B2 bar cross B1 bar is perpendicular to B2 bar and B1 bar. It means it will automatically be perpendicular to L2 and L1, and it means it is parallel to PQ. So in order to get PQ, what you will do? You will project AB bar on B2 bar cross B1 bar. Now we know the formula for projection of one vector over the other vector. What it will be? PQ is, it will be AB bar dot, see, projection of AB bar on B2 bar cross B1 bar will be AB bar dot B2 bar cross B1 bar upon mod of B2 bar cross B1 bar, and then mod of complete, because it is length, so it has to be positive, it has to be non-negative. This is the shortest distance. Okay, so I hope you understand. This is projection formula. If you remember, we have done earlier, I have taught you in vectors. You can watch that video also. Projection of A bar on B bar. What was the formula for projection? Projection of A bar on B bar. When you have on B bar, then down it is mod B bar, and A bar on B bar, so A bar dot B bar. So same thing here. Projection of AB bar on B2 bar cross B1 bar. So mod of B2 bar cross B1 bar is in denominator, and then dot product of these two vector is in numerator. Okay. So this is the complete explanation. Very simple, very simple. So now you do not, once you have understood this idea, you can write the formula without the diagram also. Without the diagram. See how simple it is. What are the two lines here, students, that we are given? What are the two lines? The two lines were, now let me write this and explain with the help of equation. The first line was R bar equals to A bar plus lambda B1 bar. What was the second line? R bar equals to B bar. See, this is the second line equation. B bar plus, okay, it should have been, it should not have been lambda, because you will not use lambda both the places. One is one of these you write lambda, the other you write mu. Okay, and then you have here mu bar. B bar plus mu B2 bar. B bar plus mu B2 bar. Okay. So now check this out. R bar is A bar plus lambda B1 bar. R bar is B bar plus mu B2 bar. What will be the shortest distance between these two lines? Listen, students. The shortest distance will be very simple. This point, this is position vector of the point on the line, and this is also position vector of the point on the line. So with these 2 points, you make AB bar. So AB bar dot the cross product of these two. You write whichever way you want. B1 bar cross B2 bar or B2 bar cross B1 bar, that is okay. Upon B1 bar cross B2 bar magnitude, and then the complete in mod, because it has to be positive. The distance is always positive. I hope you understood. I will take one more example. See, I will take one more example here. Suppose the equation of lines are given as follows. The equations are given as R bar is equal to A1, sorry, R bar is equal to A1 bar plus lambda B1 bar, and R bar is equal to A2 bar plus mu B2 bar. Okay. So what will this be, students? So what will be the shortest distance? The shortest distance. See, if it is A1 bar, if I'm given in the equation A1 bar, it means the point on the line is A1. You know, this is A1. So if it is A1, then position vector will be A1 bar. Okay, and the another point is A2. That is why it is not B, it is A2. So position vector is A2 bar. Got it? Okay, so what will be the shortest distance? Very simple. So if this is point A1 and this is A2, what it will become? It will become A1, A2. You understand? So A1, A2 bar, like you have here AB bar, that will become A1, A2 bar dot B1 bar cross B2 bar, or B2 bar cross B1 bar, that I have said so many times, upon mod of B1 bar cross B2 bar. You understand? This is how it is. This is okay. In the next step, now what is A1, A2 bar? What is A1, A2 bar? A1, A2 bar is A2 bar minus A1 bar. What is A1, A2 bar? A1, A2 bar is A2 bar minus A1 bar. Okay, this is likewise. Similarly here, AB bar, what you will write? You will write B bar minus A bar dot. This AB bar is B bar minus A bar dot B2 bar cross B1 bar upon mod of B2 bar cross B1 bar. Okay. Now you can copy this diagram and do this. Remember one thing, students, before watching this video, you should have watched the earlier video. In that, I have given the complete explanation with the help of a model. Okay, with the help of a model, what is line L1, L2, that you have to watch. Okay, please copy this and write the formula. Okay, now with relation to the shortest distance, there are some important points to be remembered. So we'll see them one by one. See here, I have written two lines intersect each other. Now two lines, they are intersecting each other. It is very important. See, the shortest distance we found, those two lines were not intersecting each other. So what happened? You got some distance between them. You got some distance, okay, some positive distance between them you got, since they were not intersecting. But here, see what they are saying. They are saying two lines are intersecting if and only if the shortest distance between them is zero. Truly said. Truly said. See, students, if the two lines are intersecting, what will happen? The distance between them will become zero. The shortest distance. Now here these two lines L1 and L2 are not intersecting. L2 is going underline L1. Okay. It's like you have L1 as a bridge and L2 is a river. So now you know the river goes underneath the bridge. Okay. The river is flowing underneath the bridge. So this is L2, like river flowing under the bridge. Okay. So, but then now here the case is the distance between two lines PQ, the distance between two lines PQ is zero. Now you can understand, if PQ is zero, it means the two lines are intersecting each other. L1 and L2, they are now intersecting each other. One point is going to be common point because PQ is zero. I hope it's clear. So the two lines are intersecting if and only if the shortest distance between them is zero. Now here I write the two lines, let r bar equals to a1 bar plus lambda b1 bar and r bar equals to a2 bar plus mu b2 bar intersect each other. Now if they're intersecting each other, what will happen? The shortest distance between the lines will be zero. The shortest distance between the lines will be zero. In that case, what will happen? You know how the shortest distance is given. So the shortest distance between the two lines here is given by, you know, a2 bar minus a1 bar, that is a1 a2 bar, dot b1 bar cross b2 bar upon mod of b1 bar cross b2 bar equals to 0. This is shortest distance and it will be 0. That is, now you understand, when will this be 0? If the numerator is 0. Okay, or you can say that this is multiplied here. The denominator gets multiplied, cross multiply, and what you get, therefore you get, therefore a2 bar minus a1 bar dot b1 bar cross b2 bar is equal to 0. Okay, this is the condition for intersection of two lines. Two lines are intersecting if and only if this is equal to 0. This is the condition for intersecting lines. Condition for intersection of two lines. You can write here condition for intersection of two lines. Intersection of two lines. You can copy this also. So here we have a question on the concept that we just did. This is from exercise 6.2 Maharashtra State Board textbook. Third question from exercise 6.2. See, the question goes as, find the shortest distance between the lines. R bar equals to 4 I cap minus j cap plus lambda times I cap plus 2j cap minus 3k cap, and R bar is equal to so and so here. Okay. Now students, you know that in these two equations, this vector and this vector here, okay, these two vectors are the position vectors of the points on the line, and these two vectors, this vector here, this vector and this vector, these are the vectors parallel to the lines. These are the vectors parallel to the lines. So what I'm trying to tell you is, see, this is your a1 bar, this is point a1, it is position vector of point a1, This is position vector of point A2 on the line. This is B2 bar or B1 bar. This is B2 bar. You got it? This is what I'm trying to tell you. So let us now go ahead, write the formula and solve the problem. So I will write the solution as, I'll write the given lines are r bar equals to 4I cap minus j cap plus lambda times I cap plus 2j cap,
जी sir.
I cap plus 2j cap minus 3k cap, 4I cap minus j cap plus lambda times. Okay, this is first line. Second is r bar equals to I cap minus j cap plus 2k cap plus mu times you have I cap plus 4j cap minus 5k cap. This is, I will write let A1 and A2 be 2 points. Let A1 and A2 be 2 points on the lines respectively. On the lines L1 and L2 respectively. Therefore, what I have A1 bar equals to 4I cap minus j cap, and A2 bar is I cap minus j cap plus 2k cap, right? So if that is the case, students, now you understand. Therefore here you have A1 A2 bar. A1 A2 bar will be A2 bar minus A1 bar, right? And what will this be? So A1 A2 bar will be A2 bar minus A1 bar. So you have minus 3 I cap. See, A2 bar minus A1 bar. So I cap minus 4 I cap is minus 3 I cap and 0 j cap, minus j cap, minus of minus j cap, that is minus j cap plus j cap, 0 j cap and plus 2k cap. This is your A2 minus A2 bar minus A1 bar. You got it. So what is A2 bar minus A1 bar? It is equal to minus 3 I cap plus 2 j cap. Now you write let B1 bar and B2 bar. See, the next I will write as, I will write it here only. So see, the next I will write let B1 bar and B2 bar be two vectors parallel to L1 and L2 respectively. Okay, so here I have now, what is B1 bar? B1 bar is I cap plus 2j cap minus 3k cap. B2 bar is I cap plus 4j cap minus 5k cap. I will now find out B1 bar cross B2 bar. You know, students, in the formula we need what? B1 bar cross B2 bar. The formula, what is the formula for the shortest distance? What was the formula for the shortest distance? The formula was, the shortest distance is A2 bar minus A1 bar dot B1 bar cross B2 bar upon B1 bar cross B2 bar. You see this? It is the projection of A1 A2 bar on the vector B1 bar cross B2 bar, on the vector B1 bar cross B2 bar. Okay, so let's do it now. So I have found out this. Now I'm going to find out this. Okay, Very simple problem. So I will now write B1 bar cross B2 bar. I write here B1 bar cross B2 bar. B1 bar cross B2 bar is, this is I cap, J cap, K cap. And for B1 bar, the coefficients of I cap, J cap, K cap are 1, 2, minus 3. 1, 2, negative 3. And for B2 bar, it is 1, 4, minus 5. 1, 4, minus 5. So here I have I cap. And so you get negative 10. Negative 10 minus of minus 12. Positive 12 minus J cap. And here you have negative 5. Positive 3. 1 into minus 5 minus 1 into minus 3. Plus K cap, and here you have 4 minus 2. So you got here 2 I cap plus 2 J cap plus 2 K cap. This is B1 bar cross B2 bar. Let us also find out the magnitude of B1 bar cross B2 bar. The magnitude will be square root of 2 square plus 2 square plus 2 square. That is square root of 4 plus 4 plus 4. That is equal to square root of 3 times 4. That is 2 root 3. This is B1 bar cross B2 bar magnitude. Okay. Now I understand here that what it will be. I will write therefore, the shortest distance between the lines. Therefore, shortest distance equals to A2 bar minus A1 bar dot B1 bar cross B2 bar upon mod of B1 bar cross B2 bar. Okay. This, and finally this all in mod. Okay. This has to be in mod because you need to have only the positive distance. So this has to be in mod. That is okay. So now you will write that is equal to, you already found A2 bar minus A1 bar, what it is. It is minus 3 I cap plus 2 J cap. Minus 3 I cap plus 2 J cap. Sorry, it is not 2 J cap, it is 2 K cap. I'm sorry, it is not 2 J cap. See, this is 2 K cap, students. So I made a mistake in copying this. It is 2 K cap. It is 2 K cap. So minus 3 I cap plus 2 K cap dot B1 bar cross B2 bar is 2 I cap plus 2 J cap plus 2 K cap, divide by magnitude of this, which is 2 root 3, and this is in mod. The advantage of mod is if finally you are getting anything negative, you will simply ignore that, because outside the mod it has to be non-negative. Now you get the dot product of this. That dot product is minus 3. The dot product is negative 3 multiplied to 2 plus, here you have 0 J cap, so 0 multiplied to 2 plus 2 multiplied to 2 divide by 2 root 3. So you get here negative 6 plus 4 divided by 2 root 3. That is equal to negative 2 upon 2 root 3. That this 2 cancels, negative 1 by root 3, but this cannot be the answer. Negative, see, you're getting negative 1 upon root 3. But students, negative cannot be the distance. That's why we keep that mod. So finally, what is the answer? The shortest distance is 1 upon root 3. You will ignore this negative sign. So you write therefore shortest distance shortest distance between the lines equals to 1 over root 3. That's it. Okay. You can watch this once again and solve it. So we have another question which is on the same concept. Based on same concept, we have to find the shortest distance between the lines. But this time you will notice that the equation of the lines which we are given, they are not in vector form. We are given the Cartesian equation of the lines. Okay. We are given the Cartesian equations of the line. So let this line be L1 line and this be L2. Now, one important thing, students, here is that these two lines are not parallel lines, that I can understand from the DRS of the lines. Look at the DRS. See, the DRS for the line L1 is 7 minus 6, 1, and here it is 1 minus 2, 1. So what does that mean? It means the two lines are not parallel. They are not parallel. And they are definitely not intersecting because they have asked us to find the shortest distance. These are two skew lines. Okay. Now, as you know, students, for finding the shortest distance between the two lines, what I need is the formula here. It says A2 bar minus A1 bar, A2 bar minus A1 bar dot B1 bar cross B2 bar upon mod of B1 bar cross B2 bar. This is what I need, right? So here you can understand A2 bar and A1 bar, these are the position vector of points on the line. So that I will get from the numerator. See these numbers, okay, that I will have to write in the symmetric form, that is x minus x1, y minus y1, that we will do. So here, this one we will get from the points on the line, and these are the vectors parallel to the lines. B1 bar is vector parallel to line, B2 bar is also vector parallel to line. So these two vectors we will get from the denominator. Okay, so just wait, in a short while we will get the whole picture clear. So here, see, I write the solution will be, the given lines are okay, I write the first line as L1. So what is L1 equation? See, L1 is, I write x minus of minus 1. See, it is x plus 1, but how I write x minus x1. So x minus of minus 1 upon 7 equals to y minus of minus 1 upon minus 6 upon minus 6 equals to z minus of minus 1, z minus of minus 1 upon 1. Okay, and what is L2? L2 I will write x minus 3, that is okay, equals to y minus 5 upon minus 2 equals to z minus 7 upon 1. Okay, I write let A1 be a point on the line L1. I write here let A1 and A2 be, let A1 and A2 be 2 points on L1 and L2 respectively, right? So what will happen next, students? The next you will get is, see, now you will get A1. So what is A1? Point A1 is, the coordinates are for A1 minus 1 minus 1 minus 1. The coordinates of point A1 are negative 1 negative 1 negative 1. Okay, and A2 are, you get 3, 5 and 7. So you get A1 bar. What is A1 bar? Minus I cap minus j cap minus k cap, and A2 bar. Now I'm writing the position vector of these 2 points. 3I cap plus 5j cap, 3I cap plus 5j cap plus 7k cap. Okay. So now what? I will write down A2 bar minus A1 bar. So Let us find out a2 bar minus a1 bar. That is the vector a1 a2 bar. So a2 bar minus a1 bar, and that will be 3 I cap minus of minus I cap, that is 4 I cap. Okay, then 5 j cap minus, that is plus 6 j cap, and this is plus 8 k cap. I got a1 a2 bar, that is a2 bar minus a1 bar. Now I'll go for, okay, this is done. You can write this as 1. I will write let. Now I'll go for b1 bar and b2 bar. So I will write here let b1 bar and b2 bar, let b1 bar and b2 bar be two vectors parallel to L1 and L2. Okay, so I have therefore b1 bar equals to 7 I cap minus 6 j cap plus k cap. See how I wrote this vector? I wrote this vector from the DRS of L1. You see this? 7 minus 6, 1. 7 minus 6 and 1. So here I wrote. So here we have B1 bar from the DRS of L1, and see what will be B2 bar, and B2 bar I will write from the DRS of L2, which is 1 minus 2, 1. So what you will have I cap minus 2j cap plus k cap. What is next? We will find out B1 bar cross B2 bar. You know why I'm finding this, because it is required in the formula. So B1 bar cross B2 bar will be I cap, j cap, k cap, and here I have 7 minus 6, 1. B2 bar is 1 minus 2, 1. Okay. Now I will find out. So this is I cap and minus 6 plus 2 minus j cap, and here you have 7 minus 1 plus k cap, and you have minus 14 plus 6, minus 14 plus 6. So this is minus 4 I cap minus 6 j cap, and this is minus 8 k cap. This is B1 bar cross B2 bar. I have got it here. So what is next step that I will write? So the next step I write is mod of B1 bar cross B2 bar. Mod of B1 bar cross B2 bar, and see what it will be. It will be square root of minus 4 square plus minus 6 square plus minus 8 square. So I get therefore B1 bar cross B2 bar is equal to square root of 16 plus 36 plus 64. That is square root of 116. Okay, square root of 116 we got. That's fine. Now I write the shortest distance equals to mod of a2 bar minus a1 bar dot b1 bar cross b2 bar upon mod of mod of b1 bar cross b2 bar. Got it? Now see students, the next step is you have already found, you have made the provision of these vectors. A2 bar minus A1 bar, what it was? It was 4, 6, 8, 4 I cap plus 6 j cap plus 8 k cap dot B1 bar cross B2 bar is minus 4 I cap minus 6 J cap minus 8 K cap upon square root of 116. Square root of 116. I put this in a mod. So the next I get here is 4 into minus 4 is minus 16, minus 36 minus 64, minus 64. Okay. See, 4 into minus 4 plus 6 into minus 6 plus 8 into minus 8 upon square root of 116. So this is equal to negative 116 upon positive square root of 116. That is equal to square root of, now you understand this is, in the numerator I have 116, in the denominator I have square root of 116. So finally the answer I'll get is square root of, I'll get square root of 116, but that will be negative inside the mod. But you know, we have put the mod for the same reason that we do not want to get negative in the answer. So outside the mod, what it will be? It will be 116 inside the mod. This is the shortest distance. Root of 116 is the shortest distance. I hope you followed it. Please copy this. Watch this again. The square root of 116 you can write root of 29 into 4, and that will be equal to 2 root 29. What will that be equal to? So the shortest distance will be 2 root 29. So here we have another question, that is number 7, which is put in this way. See, it says, by computing the shortest distance, determine whether the following lines intersect each other. You have to determine whether these lines intersect each other. Okay, so the first one is r bar equals to I cap minus, see the first question they give us two lines, r bar equals to I cap minus j cap plus lambda 2I cap plus k cap, and the second line is r bar equals to 2I cap minus j cap plus mu times I cap plus j cap minus k cap. So what we have to do here, we have to find the shortest distance between these two lines. As we found in the earlier two problems, we will do the same here. What we will do, we will find out the shortest distance between these two lines. This is, say, line L1 and this is L2. Okay. If I get the shortest distance equal to 0, then what I will say? I will say that the two lines are intersecting each other. Okay, I will find out the shortest distance. The formula you know, A2 bar minus A1 bar dot B1 bar cross B2 bar upon mod of B1 bar cross B2 bar. This is how you will do it. Okay. If you get the distance 0, then you will say, if you get the distance 0, you will say that two lines are intersecting each other. They are saying determine whether the following lines are intersecting each other. And in case if you get a number which is non-zero, if the shortest distance is not equal to 0, what you will say? You will say the two lines are not intersecting each other. You will say the two lines are not intersecting each other. I hope it's clear. You will say the two lines are not intersecting each other. The same way you will solve this question. Okay, and here, see, the first question, two lines are given with the equation in vector form, and the second question, the two lines are given with the equation in Cartesian form. I have done both the types. When the vector form is given, then how to find the shortest distance, and also when the Cartesian form is given, then how to find the shortest distance. So these two problems are homework for you, and you will solve them. So I give you the answer for both the questions. The answer for the first one is the lines do not intersect. Do not intersect. What does that mean? It means when you will find out the shortest distance, you will not get 0. And for the second one, that is these two, the answer here is the lines do not intersect. Even in the second one, the lines do not intersect. You should all definitely solve these problems. Okay. So here we have the final question on this concept. See, what does it say? It says if lines, they give us two lines. They give us two lines here. X minus 1 by 2 equals to y plus 1 by 3 equals to z minus 1 by 4, and x minus 3 by 1 equals to y minus k by 2 equals to z upon 1 intersect each other. They say clearly stated, here they have stated the two lines intersect each other. We have to find the value of k. Okay, we have to find the value of k here. This is the unknown. Now this unknown which you have to find, it appears to be here in the question. You see this? Here is where you have k. So k is an unknown we have to find, and k is the coordinate of one of the point on one of the line. Okay, so I will write here the given lines are, the solution starts. I write the given lines are, so here I have L1, which is the given lines are L1, which is x minus 1 by 2 equals to y. Now see, this is y plus 1. I will write y minus of minus 1 by 3. You know, this is the way you should be writing symmetric form, so that you could write the coordinate of the point on the line. Y minus 1, y minus of minus 1 equals to z minus 1 by 4. And L2 line is x minus 3 by 1 equals to y minus k by 2 equals to z minus 0. See, this is only z, so z minus 0 by 1. Okay, so I will write here, let A1 and A2 be 2 points on L1 and L2 respectively. So I have therefore A1 as 1 minus 1 1 and A2 is 3k and 0. So the next I will have is A1 A2 bar. So A1 bar will be A1 bar, which is position vector of point A. It is I cap minus j cap plus k cap, and A2 bar will get as 3i cap plus k j cap, 3i cap plus k j cap plus 0 k cap plus 0 k cap. Okay, this k is unknown for us, remember it. I'll go for A2 bar minus A1 bar. So A2 bar minus A1 bar, you will get 3 minus 1, that is 2i cap, then kj cap plus j cap, that is you will have k plus 1 j cap, kj cap plus j cap. When you take j cap common, it is k plus 1 times j cap, and 0 k cap minus 1 k cap, that is minus 1 times k cap. This is A2 bar minus A1 bar. This is important. I will go for, now I'll go for the vectors parallel to L1 and L2. I will write let B1 bar and B2 bar be two vectors, parallel to lines L1 and L2 respectively. L1 and L2 respectively. So what we will have? So therefore B1 bar is 2i cap plus 3j cap plus 4k cap, and B2 bar will be I cap plus 2j cap plus k cap. What I'm going to find out is B2 bar cross B1 bar or B1 bar cross B2 bar, right? Therefore, B1 bar cross B2 bar is, you will have I cap, j cap, j cap, k cap, and you have here 2, 3, 4. 2, 3, 4, the coefficients of I cap, j cap, k cap in B1 bar, and 1, 2, 1, 1, 2, 1, right? 2, 3, 4, and 1, 2, 1. So what you will have, therefore, I cap equals to I cap into 3 minus 8, 3 minus 8 minus j cap into 2 minus 4 plus k cap into 4 minus 3. So this is minus 5 I cap plus 2 j cap plus k cap. What is this? This is B1 bar cross B2 bar. Okay. Now students, you know, when the two lines are intersecting each other, the shortest distance will be 0. I write here, we know that for two intersecting lines, the shortest distance between them is equal to 0. Okay. Therefore, A2 bar minus A1 bar dot B1 bar cross B2 bar upon mod of B1 bar cross B2 bar is equal to 0. And you know, this would be 0 when the numerator here is 0, which you could have written this directly also, because we have already done this as a condition. But then in case if you don't remember, I'm doing it with the help of the formula itself. I'm doing it with the help of the formula. So this is the formula, students. So this has to be 0. This is the shortest distance. Now the shortest distance has to be 0. So I have written 0. Now what? Therefore, you have A2 bar minus A1 bar dot B1 bar cross B2 bar equals to 0. Now substitute these vectors and get an equation in which you will find k and then solve for k. So here you have A2 bar minus A1 bar is 2k plus 1 minus 1. So you have 2i cap plus k plus 1 j cap minus k cap. 2i cap plus k plus 1 j cap minus k cap. Dot. Here you have B1 bar cross B2 bar, which is minus 5i cap plus 2j cap plus k cap. equals to 0. You know how to find the dot product? It will be therefore 2 multiplied by minus 5 plus k plus 1 multiplied to 2 plus minus 1 multiplied to 1. See, the coefficient of k cap here is minus 1 and here it is plus 1 equals to 0. So you have therefore negative 10 plus 2k plus 2 minus 1 equals to 0. So you have here 2k, this is negative 9. 2k minus 9 equals to 0. So k equals to 9 by 2. I hope you understood. This is an important problem. You must watch this again and solve it. Thank you.